Partially filled arrays in C++. What are they? They're arrays with a known capacity, but not all their slots are actually in use. You'll usually find these in programs where the number of inputs or entries isn't known up front, maybe because it depends on the user input or file size. But you still want to pre-allocate space ahead of time. Let's break it down with an analogy. Imagine you're running a movie theater. You've got a theater with exactly 100 seats. Now let's say there's a screening of a movie and only 35 people show up. What should you do with the 65 other empty seats? You can't just rip out chairs from your theater to save space. The seats were built into the theater. So instead, you ignore the empty ones. You still have a capacity of 100, but only 35 are being used. And that's the concept of a partially filled array. It's fully allocated, but only partially used. Now here's the next big question. How do you know how many people are actually in the theater? Well, imagine you install a turnstile that counts people as they walk in. Each time someone enters, the counter increases. That turnstile counter is your num used variable in code. It keeps track of how many elements of the array are currently filled. The important thing here is that you control the account. If you loop over the full size of the array, you might be trying to access memory that was never initialized, and that's the recipe for garbage values, bugs, or even crashes. Let's talk about why this matters. Imagine you want to give each person in your theater a coupon. You might write code that loops through the array and adds a coupon amount to each attendee. But what if you looped all the way to size instead of num attendees? This would try to add a coupon to people who don't exist, like stuffing coupons into empty chairs. Not only is that a waste of resources, but worse, in real code, you're modifying values that might be uninitialized, meaning that they contain random junk values. What happens if you add 2 to an uninitialized integer in C++? I don't know. You don't know. The compiler won't tell you, but your debugger might, after it all breaks down. That's why tracking the valid portion of your array with a counter is absolutely necessary. It's not just good practice. It's essential if you don't want to be chasing phantom bugs all semester. Let's shift from metaphor to real-world use case. Suppose you're writing a program that reads test scores from the user, but you don't know how many scores the user will enter. You give the user a fixed maximum, let's say 100, but allow them to stop early by typing -1. Here's how it might look like in code. The constant integer max determines the size of the integer array, scores. The array size can't be changed, so it has to be a constant. Num scores is used to track the amount of scores that's entered in an array. It's 0 for now because the array is empty. A while loop is used to keep inputting scores into each slot of the array. The loop terminates if we input -1, which is a sentinel value, or if we fill the entire array with scores. Num scores increases every time the loop is run. Now, you've got a partially filled array of test scores, and you know exactly how many were entered with num scores. You can now safely loop from 0 to num scores -1, not max, to calculate averages, find the highest score, or sort the entries. Let's talk quickly about sorting. Imagine you're applying a bubble sort to the array. If you mistakenly loop through all 100 entries, including the unused part, you're going to be comparing real data to garbage values. That's a surefire way to corrupt your results. So again, working with partially filled array means you must know how much is filled. Now you must be thinking, why not just use a vector? And that's a fair point, vectors automatically manage size for you. They grow and shrink dynamically and they track their own size so you don't have to keep count. But sometimes, you're working in environments where arrays are required, or you're practicing core C++ fundamentals. Understanding how to manually manage size and validity is essential, especially if you're preparing for interviews or working with legacy code. So to recap, a partially filled array has a set maximum capacity, but only part of it is actively used. You must keep track of how many elements are valid using a counter. Looping through a full array without checking the valid count leads to unified behavior. Partially filled arrays are common in basic input programs, data buffers, and older C-style code. And that's it. That's your deep dive on partially filled arrays in C++. Just like in a movie theater, know how many seats are filled before you start handing out popcorn, or coupons, or memory operations. Happy coding!